So this is known as Boyle's law apparatus. It is a old-fashioned kind of style bicycle pump, and then we're pressurizing the water in here. So we're pumping from here, and then this water level is going to rise. The water's got some purple dye in it, so that hopefully you can see it. Water level is going to rise, but what we're actually interested in is what's left. It's sealed at the top, and we're interested in this column of air. As we increase the pressure, the column of air is going to get smaller. So we increase the pressure, the volume reduces. That's why the 0 is at the top of the scale here. Right, so we're going to increase the pressure, the volume of this column of air is going to decrease, and so we can measure pressure and volume. That should mean that, I guess if we wanted to, we could measure, we've got this pressure on this dial here, so we could read off the pressure, which is, I think, 0.9 times 10 to the power of 5 pascals. And we could read off the volume. It doesn't matter what the units are here, to be honest, because we're timesing them together to make a constant. As long as we keep it the same, it doesn't matter. So we could do this 40, it's almost 47, isn't it? Let's say it's 47 for argument's sake. 47 times 0.9, give us some constant. And then I could say, oh, well, what will the pressure on this be when I get my water level to 37? And we could work that out because we know this, we know the constant, we can then use our equation to find the pressure on the dial here. But that's not what we normally do with experiments. Normally in experiments, we change something, we measure something else. What we do with Boyle's law apparatus is we're trying to verify the fact that pressure times volume does give us a constant. So we will change the pressure and we're going to measure the volume, and then we can plot a graph of volume against pressure. A graph of volume against pressure should be a curve. So if we draw a graph, we've got volume on here, we've got pressure against here. We know that for a large volume, you've got a small pressure, and for a large pressure, a small volume, you've got a higher pressure. And actually, because of the way that the equation goes, so this is, if you remember from maths, if you've got like a y equals 1 over x graph, it's going to look like this. Well, actually, we've got a v equals constant divided by p graph, and so it's going to look like this. So if we get a nice curve here, then we can verify this relationship essentially, and that is what we are going to do. I'm not actually going to take data from this apparatus, although I kind of would normally actually, but I'm just going to show you. As I pump it up, so the pressure goes up, the volume goes down. Remember, I'm talking about the volume of this column of air here. So that volume is going down and the pressure is going up because I'm interested in the air, remember, not the liquid. I'm interested in the air. Should have shown you earlier, it is sealed at the top, I just can't get it in the shot. Okay, and so we could take data, I could read off lots of different volumes, read off lots of different pressures and get you to plot a graph, but I think that would take a long time, and I don't think it's particularly beneficial when we can just get data from that's already been collected in a question. So, but that is what you do with this equipment. Just want to draw your attention to something else though. As I pump it up, we can see the level goes up here, but then actually it goes down a little bit afterwards. I don't know if you saw that, I'll try and do it again. It goes up, and then after a while, it sinks a very, very small amount, not much, very small amount. Actually, it was worse. It was sinking a lot more when I had it. Just going to get it back to how it was at the very beginning, the kind of first one, and that's because the volume of air was larger. If I do it here, so it goes up and then it drops just a little bit. Just I'm sure that's noticeable on the camera there. That's because the temperature of the column of air is changing, and this pressure times volume equals constant only works if the temperature remains the same. So we have to leave it a little bit for the temperature to get back to room temperature, whatever temperature it is in S6 today. And so we would normally wait until this goes down and then read it when it's level, because we want to keep the temperature of the column of air the same. Otherwise, our kind of rule of pressure times volume equals constant will break down.